Hi, good morning, good afternoon, good evening, wherever you are. I hope the weather is better for you than it is for me. It's kind of intermittently wet and muddy here. My name's Kevin Henney. I'm based in Bristol, and what I want to talk about is this idea. There's a quote that people use, the idea that you should use the right tool for the job. And we see this in software development. People use this as a phrase. We also see it elsewhere in other disciplines, but I'm going to focus on software development for now. The intent of it is self-evident, that if you're doing something, then do it the right way, do the right thing in the right way. The problem is, once you scratch the surface of that and deconstruct that sentence, you discover it is anything but self-evident. It's not at all obvious. So the first question, the first challenge, and the first assumption that we encounter is the idea of the right tool. When we say the right tool, it makes it sound like there is uniquely one, there is a chosen one, and that it is self-evident from all the other possibilities. Now, perhaps if what you're doing is simple enough and your options are reduced enough, maybe two, then there is one of those that is more right than the other. But we should already be on our guard here. We should already get the idea that right is not the right term. There is the idea of more or less appropriate. And what defines appropriateness is based on a number of factors. Again, not self-evident. If you're dealing with tools that you know versus tools that you don't know, how do you know that the things that you don't know may be better? And even if somebody urges you and tells you they are better, you may have preconceptions about them. You may also have a knowledge acquisition time. And if acquiring that knowledge is going to be more expensive and take longer than is proportionate for the task in hand, then that's not the right tool, is it? And this is kind of an important consideration when we think about ecosystems of software, when we think about programming languages, when we think about all of these things. It is not always obvious that the right tool is an obvious thing. So, for example, a number of years ago, I was working in a bank, and one guy came to me with a particular problem related to text, and he had been told by one of my colleagues that he should really think about pre-processing. And I said, yeah, that sounds reasonable. And he said, yeah, and I was recommended to use the C preprocessor, which I did not think sounded reasonable. It did feel like the wrong tool. He was dealing with free text in English, and also kind of semi-formal formatting. And the C preprocessor has a relatively narrow scope of applicability, and certainly for people in C and in C++, they have horror stories of even how appropriate it is in those contexts, or how inappropriate it is, and how troublesome it can be. So I recommended to use a different tool. I recommended to use a lesser known Unix tool, M4, which actually is targeted at pre-processing, is highly configurable, and will work with regular text. Now, what is interesting there is that he'd never come across it. Well, that's not that interesting, it's not surprising. How would he have known that there was a better option available? But what is more interesting is the reaction of my colleagues who made this other recommendation. They came to me and said, somebody's gone and recommended M4. And it turns out that the two colleagues, one of them had never used it, and the other one had had a bad experience. We are often influenced by our experience and our preconceptions. They'd had a bad experience. They had probably used this for something that it wasn't appropriate for, or gone in ill prepared. So there is an idea here that the self-evidentness of what is the right tool is not always obvious. In some cases, it's only obvious in hindsight, and with that kind of learned and greater context. And there are some things that we can say with some confidence. I'm old enough that the first proper paying job for programming that I had after university was at a place where we used some very traditional languages. Fortran, COBOL, some variant of BASIC, and PL1, not so much, but that was present. This place did not use C at the time that I arrived. And one of the main things that we did was systems programming. This involved factory automation, amongst other things. And one thing I can say with hindsight is that Fortran really is the wrong tool for this job. It is a slow and painful way of doing something that is far better done in other languages. But of the languages that were available, it kind of did seem the obvious one. But then, while in my tenure there, I did end up using C. And the sensation of using C, having learned Fortran, was the sensation of no longer hitting your head against a brick wall. In that case, C was this perfect match. It's not only a better design language overall, it was intentional rather than cobbled together. If you think that I'm being harsh on Fortran, you should look at its history. It literally was cobbled together by John Backes and his team, basically to prove a point. However, that's a different story. The point there is that it was singularly unsuited to a number of things: structured programming, data structuring, and systems programming, all of which were things that were relevant in the context that we were in. So once you've broaden your scope, you can say, oh yeah, actually there are better options, but they are not immediately obvious, and that was defined partly by our experience or our inexperience. That was shaped by it. Hindsight has given far greater sight than that, which is why we want to draw on the knowledge of others, certainly those that we can trust, but we also need to weigh up against other factors. What is the training and learning cost? I'll be quite honest that back then my C, when I started, looked like C-Tran. It was kind of like C spoken with a very heavy Fortran accent. But nonetheless, the improvement was huge. So there is the idea in a number of cases that we can make a judgment and we can step back, but we often don't allow ourselves to do that. So another example, a team that I visited a few years ago, there was a team of 4. They'd spent 6 or 7 months doing some Java code, screen scraping off a mainframe, and this was primarily text manipulation. Now, this is not Java's forte. This is not Java's strength is in its ecosystem and its universality and a number of other factors. But honestly, text processing is not where I would put its strengths. And what is interesting is that after spending some time with them, I kind of came to the conclusion. I said, you know, you guys would have been a lot better off had you had a team of 2 and used Python. You'd have been done in just a handful of weeks, maybe even a month. Now, what was their obstacle there? Well, clearly they didn't know Python. In fact, the culture of the place was large projects, so people were immediately suspicious of anything that was small. They were also not as familiar with dynamically typed languages or anything that feels and looks like a shell language. That was not their culture. Java, C#, C++ was their culture. Shell languages were only glue languages. They were not considered to be principal first-class engineering languages. And so there is this other aspect that when we reduce the job to something simple, sometimes it is easy to tell what is needed and what is not, or what are the characteristics that we want. We often don't make a trade-off, we don't make an evaluation. But there's another problem that we encounter with the right tool for the job. Let's be very clear, tools are not for jobs. Tools are task-oriented. There's a very subtle difference. Most of the time it doesn't matter, and there are indeed occasions when we use the term job and task interchangeably, and some jobs are reducible to one or more simple tasks. So an example of that many years ago was a simple small application that I developed, and it was reducible into 3 basic parts, 3 basic paradigms, and there was actually a tool for each job. I used shell scripting for, as it were, the coordination language, the argument file handling, the options handling, and that was the entry point. Then I used awk for the data processing, or rather the text formatting, and handling the content and structure of the file. And then for the numerical and computational part, which was significant, I used C. But all of these could be put and arranged in a very simple pipeline arrangement, and it was very task-oriented. Sometimes our tasks really do dominate the job, but in many cases they don't. The task is not the thing that is fitting to the tool, and the tool, when we say a programming language is a tool, we need to understand that that's a metaphor, because programming languages have typically many degrees of freedom. when people talk about tools in the real world, things like hammers and screwdrivers and things like that, they're talking about things which have relatively few degrees of freedom and apply to simple domains where the conclusions are obvious. Software development on the whole is almost exactly unlike this. Of course, there are certain cases where there are things that are more or less obvious, and we can equate a particular domain with a particular shape of problem and therefore correspond it to a tool that is finely tuned to that. Most programming languages have multiple dimensions of possibility. They are general purpose, they are not simple tools. They are collections of tools. So the right thing is looking harder and harder by the second. There's a lot of context we have to take into account. But there's also one other aspect, that even when we've recognised that tasks are not necessarily jobs, jobs are composed of many tasks, and tools are primarily geared towards tasks, design challenge is far larger than this apparently self-evident statement. There's another thing that we need to encounter. How do we know what the job is? A lot of things in software development are based on the fact that we don't know what the job is in advance. That the very act of development is what reveals the job. That if we try and make all these decisions up front, we are doing so from a position of greatest ignorance. When do we know the least? Right at the start. When do we know the most? Well, further in. And if it is actually a project, then it has an end point. That's when we know the most. But we made all the big decisions back about the right tool for the job. Our preconceptions of what the job involved have shaped and perhaps distorted and prevented us from actually using the right tool. So, I'm going to wrap this up as the sunshine comes out.